Anita, that's fine. It's freaking hot. You're right. It is so hot. Oh God. I'm having to have to walk my 4 dogs at 7 o'clock in the morning. Yeah, I know what you mean, Biani. All right. Any questions? Any questions about anything that we have covered? We've covered a lot of stuff. Crickets, crickets, crickets. No questions. Okay, no, no one, everybody should have their lab. No one should have their lecture exam done, or they should not be able to see it. I have not posted that because I'm trying to decide on what to do. Boom, 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 boom. It's, yeah, I'm, yeah, not great, not great. But don't freak out. I just need, I need a little bit of time. I think I met Samantha's funny, Nikisha. Not everybody did bad, but the class average wasn't great. So, and I think I mentioned that before, that I said that I typically give a curve on the first test because it's a little bit of a shock. So I just have to decide how much of a curve. Andy, you have a question, Andy?
Yes, sir. So, kind of the consensus was that the time seemed to be like the biggest challenge. And I know personally, I'm an extremely fast test taker. I've never struggled with time tests. And I know kind of in the lecture that we had previously, when you kind of spelled out, what are some shortcuts that we could use to structure our sentences, that sounds great, but it's because you're so familiar with the language and the jargon. And I know for a lot of us, it's a struggle. This is new territory for us. And so just to kind of pull those words from your mind and make them make sense in a sentence, it's difficult, and it does take time. It takes more than a minute and a half on a lot of these. Like, I know just putting the negative feedback examples, of course that's going to take more than 2 minutes, which is kind of the average that we have on each question. So I think that seems to be where a lot of the trouble lies, because I know certainly I studied, and I know just from our GroupMe thing that there were a lot of folks meeting up to study together. So it wasn't a lack of studying or not knowing the material.
Point taken. So I've given that great consideration because other people have given me that feedback offline. Yeah, I will add more time to the next tests, the following exams. Okay?
Well, thank you for considering that. I really appreciate it.
Yeah. So this exam you had 70 minutes. So I think I'm going to give you 85 minutes on your following tests. Okay? I'm going to give you an extra 15 minutes.
Thank you.
All right. Like I said, so it's a fine line between, since I don't have I'm not doing proctoring or lockdown and all that other stuff. It's a fine line of how much time I should give versus how much time you're going to use looking stuff up. So I'm still working on that. Daniel, question.
It's just to basically jump on what Andy just elaborated on. I know you said 85, sir, but could you add 5 more minutes? Am I pushing it if I ask for 5 more minutes? Because with that exam too, I didn't get a chance to even look over anything that I typed. And I also didn't finish. So usually I'm also a fast test taker. I can go through, select, and whatever. It's not that we didn't know the knowledge, but we literally, as she said, there's like 2 minutes per question. And with 85, I know that's 15 minutes extra, but if maybe 90 minutes, I'm just saying, like, it's up to you, of course.
And the other thing is, even with that extra time, if folks didn't study, that's still not going to be enough time for them to have the material, because your questions are pretty detailed, and you are very fair. It is true that you do give us a lot of hints and feedback as far as what to study. So if these folks didn't take advantage of that, they're not going to get through the test period, even if you give them 2 hours.
I agree with
Andy,
Professor.
Okay, Andy. All right, Andy, you sure you don't want to go to law school instead?
No, sir. I have kids. I'm a great negotiator.
Okay, 90 it is. 90 it is.
Thank you, Professor.
Okay, so everybody thanks Daniel and Andy. All right, they won me over. Samantha, question.
Okay, one more test question. Can you hear me?
Yes.
Okay. So will our test be like the same amount every time? Like, will we have 38 questions, or will we have more, even though you're like extending the time?
No, they're not going to be exactly 38 all the time. If you noticed on that test, your test, there were some that were, very short, and then some that were very long. And so depending on the material, I can assure you that this test will probably have more questions, but there'll be a lot of short ones. All right. And we'll talk about that. But no, they're not going to be the same, but I will, regardless, I will give you 90 minutes for the rest of the tests. Okay.
Okay. Thank you.
But no, Christine, not right now. Not right now. Because that may freak out some people. So just give me another day. I'm going to just take some time to ponder. The grades went from 87 to 35. I'll say that. That was the range. Yeah. So that's fine, Christina. That's what I said when I saw the grades. Okay. All right. So again, I will give a curve on this one. Maybe 70 minutes, although I've been teaching this online, but I'm trying to refine this as we go along. I probably mentioned this, but I never had any intention of teaching an all online course before, but it seems to be in demand. So we're still tweaking it. I'm still tweaking it. But like I said, I don't want to have to do there's a lot of professors do the proctoring where they're watching their students, and there's privacy issues as far as I'm concerned. When you have to show your face and your house and you have kids and all that stuff, I just don't want to deal with that. I think most of you would understand. So I don't do any monitoring. Yeah, and it's a nightmare for a lot of my faculty. And like I said, as a department chair, I heard all their issues and all the complaints, and I got many student complaints. Again, a lot of it had to boil down to privacy issues. So this is the only way I can ensure that you're not doing a whole lot of cheating. I assume that you're going to, if you can, take a quick look at your notes, and that's fine. That's still part of the learning process. But so it's evolving. It's evolving. But yeah, Daniel, it is a nightmare, and that's why I don't do it, because of all the nightmares I heard from my faculty and their students. So, but I'll agree to 90 minutes. All right, and we'll talk more. No, we talk now. All right. Look, folks, I'm not kidding. If this is the biggest issue I have, if one of your answers involves terminology I have never spoke, you didn't hear it come out of my mouth, I have to assume two things. You're smarter than me, or you looked it up. And which one am I going to have to default to?
Wait, can you say that again? So if we include terminology that is beyond the scope of what you taught, that's what you're...
Exactly.
Okay,
exactly.
I got you.
All right. So, for instance, and more than one put this, and you know who you are, but if... oh, goodness gracious. I'm trying to be delicate here, but when I asked for a hormone that the adrenal cortex produced, and you give me something like dihydroprototestosterone, you know you didn't hear that out of my mouth. What should have been your answer? Come on. Crickets, huh?
Acetylcholine?
No. The adrenal cortex, it would have been a steroid, but it should have been just testosterone or aldosterone. But when you use one of the precursors, yeah, thank you, Nikisha and Jessica. But if you use a precursor, then I'm like, okay, that's graduate level knowledge about, yeah. So yeah, Nicola, that's what I would expected. But more than one of you put something that is, like I said, graduate level stuff, because yes, your body takes basic substances and creates estrogen, testosterone, progesterone from precursor molecules, but I never went there. So I have to assume that either you're an expert in endocrinology or you looked it up. So that's just your warning, because I will not tolerate it. Don't try to impress me with your extra knowledge that you have. Just what I presented. Do I make myself clear? I don't want to see any.
Yes, sir.
All right. I don't want to see any terminology that is not on your slides. I never said. It's not in your outlines. Okay. So you may be that expert in endocrinology, or perhaps just your steroidal hormones, but don't do it. Don't do it, because I sit there and go, where the heck did they get that from? You know? In the past, I'm not kidding. I'll just say it. In the past, I have had students that gave me an answer that I had to personally look up to figure out where they got that from, because I had never heard of it before. And so that's not good. That's never a good thing. All right. Okay, so we've... Sharish, the only way I can do that is to have a schedule a one-on-one session with you. I can't do that for the whole class. I don't, that's one of the problems with this online stuff. It's, come on, a lot of you are pretty savvy on the technology today where you can sit there and screenshot everything. Andy, I believe you don't, but there are those that do, because there are websites and apps that pay people to give up test questions. You do know that, right, Andy? There's
No, but now I'm about to go get paid.
okay.
The money.
Yeah, show me the money. But no, it's a business, and our faculty are well aware of it, and we actually have a task force that looks at these websites to see if indeed their tests are showing up on these websites, because there are websites that will pay you to give up test questions from a particular professor in a particular course. So yeah, and like I said, it's so easy to just take a screenshot and save all those screenshots and turn around and sell it. But if you want,
Professor, you don't give us enough time on the test to take screenshots.
I don't know. I have a Mac. It takes 2 seconds. Command Shift 4. Boom. Done. But anyway. But yes, if you have issues or if you want clarification, and then like I said, once I will publish the grades tomorrow, so you see them on your Blackboard. And then individually, I'll be more than happy to discuss them. We can set up an individual Blackboard or a Zoom meeting to go over the questions. And if there's any Hymas stuff, we can go over there next. We can go over the Hymas stuff next week. But this is just the limitation of online. If we were in the classroom, I'd hand out your tests that you have taken on paper, and we would have gone over stuff. But like I said, I have to be very wary of anything that I put online. So, okay. Any questions about the actual? Stop it, Cindy. You don't know how you did. And like I said, I don't want anybody to be super afraid. Like I said, not everybody did bad, but enough did bad where I have to consider a curve. And that will help you. Some of you, okay, I'll say this, all right? Some of you did well enough where if I give a curve, that puts you in the high 90s, all right? So, sleep on that. Okay. Jennifer, that's exactly what I'm having to decide. I don't know how much the curve is. I have to think about it. I have to think about it, what's fair. All right? It's just one of my old, oh God, I'm going to give you another anecdote. But, I took way back when, I'm going to say how long ago, when I took physics, we started with 40 students. And by the end of the semester, we were down to 12 left in the class. It was a hard class, but I busted my butt. And I had a little study group, so 3 of us did really well. We got in the middle 90s, like 95, 94 for all of us. The professor gave, at the end of the semester, a 15-point curve. A 15-point curve on our final grade. So now I'm sitting there with 110. And I'm thinking, oh my gosh, so somebody that got an 85 also gets an A. And at that time, I was shooting for med school, and I just thought that was wholly unfair. Does everybody understand where I'm coming from? And you guys are in competitive programs. Most of you want to go to nursing school or dental hygiene school, and you should resent the fact that if you got a legitimate A and I gave a big old giant curve at the end and somebody that was in the low 80s is now an A student, yeah, you should resent that a little bit, all right? Because it's competitive. Our dental hygiene program is super competitive. So anyway, that's just my thoughts. Okay. But like I said, there will be a curve on this one. But if I go to 90 minutes because of Daniel and Andy, then there won't be any more curves. And once again, if you're taking good notes, there should be no surprises on these tests. None. All right. So no questions on previous material. Okay, Andy, but what if they spend all their time looking stuff up, so their first 25 questions are perfect,
Yeah.
and then the rest are blank?
Right.
Do
So
they
that's
do-
what I'm saying. So you take the average of how many, if 15 of us didn't complete on average 5 questions, then just take that off of the total accumulated score, right? Now those folks that only completed 5 questions, those are the folks that spent all of their time looking it up. Well, those other questions are counted as zeros because you took the average. And I'm sure I would be on the short end of the stick because I know I didn't complete my test, but I think that's a way that you're still able to give people credit where credit is due. The ones that did complete the test or did do well, and then you're still grading on answers. You're not just giving people points.
Well, I'll take that into consideration, but let's hope that the 90 minutes gives you time to finish the test. So I'm giving
Yes,
you
sir.
extra 20 minutes. All right, let's see. So yeah, okay. Okay. So learning process. But like I said, I got to make sure that, because I've seen that, Andy. I've seen where students did the first 25 questions were absolutely textbook, and I mean textbook perfect, and then the rest are blank. I'm sorry, that's a extreme indication to me that they were looking stuff up. But I'll take your proposal under consideration. But let's go with the 90 minutes and see what happens, okay? Yeah, the first test is going to be curved. I just have to decide how many points it would be, all right? I don't want to make a curve where somebody ends up with 105 on their exam, okay? So I have an elaborate curving system. If you got a 35 on the test, I may give you 20 points just to keep you in the ball game until the next exam. But if you got a 90 on it, I can't give you 20 points. All right, enough of that. We'll discuss this more later. So no questions on previous material. Everybody knows everything they need to know about the vascular system. Is that what I'm hearing? And the blood. Nothing. All right. Nothing. All right. Let's knock out the lymphatic and immunity. All right. This is one of my favorite subjects, to be honest with you, and I'll explain that as we go along. The lymphatic system is really simple. Pay attention. Take notes on what I tell you is important and what is not. On the lymphatic, the immune system.
JJ!
What the heck was that? All right, someone's got their mic on. So here we go. So the lymphatic system is very weird because it has several functions that don't seem to be even remotely related. Now, I just touched upon that earlier. Yeah, I don't know. Sounds like me yelling at my dogs. But anyway, so the lymphatic system is weird because we got everything from, transporting excess interstitial fluid back to the bloodstream, which we talked about. But it also is a big factor in the immune response, and it's involved in transporting dietary lipids. That doesn't seem like they're remotely related. The fluid back to the bloodstream and the immune system, that's related to some extent, and we won't talk about this, but you need to know it for the test, that it does involve transporting dietary lipids through the circulatory system. Okay, someone says, do I record this? Let me see, how many students do I got? I got 21 students, so that meets the criteria. So I will record. Boom. All right, so we're being recorded. Okay, right. So I just gave you the functions, and again, this the lymphatic system, very, very simple. Not anywhere close to the cardiac and vascular and blood stuff. All right. So we have lymphocytes, lymph nodes, lymphatic, everything starts with lymph in there. Here's a study slide, write it down. So this is your pathway through the lymphatic system. So we have lymphatic capillaries that pick up the stuff that leaked out of your cardiovascular capillaries. And those capillaries merge to the collecting vessels. All right. And then they enter lymph nodes. Then they exit the lymph node and merge into lymphatic trunks. And the trunks merge to form the ducts, which empties all that fluid back into your circulatory system via the veins in your neck, which we'll talk about. All right, so here we go. All right, so you have your capillaries. They're again very simple, simple squamous. They have these little flaps that allow stuff to enter, and again, they're very porous, so they allow everything that might be circulating in the capillaries and your interstitial fluid, like bacteria, viruses, cancer cells, things of that nature, infected cells. And we'll explain exactly what happens there. And then something completely different that has nothing to do with the immune system is these lacteals, all right, which we will discuss in great detail when we get to the digestive system. So over here in the bottom right-hand corner, this is a little picture of your small intestine. And you have these lacteals that pick up all the lipids that you ingested and transport them to the lymphatic system first and then back into the circulatory system. So just keep that in mind. Don't make a big deal about it on this test. Just be able to tell me that part of the lymphatic system is lacteals that receive digestive fats. I'll leave it at that. So the capillaries merge to form these collecting vessels, and they have the same kind of structure as our regular blood vessels. So we have a tunica intima, media, and externa. Lots of valves, one-way valves, like on your venous side. And again, they're kind of propelled the same way as the venous system, skeletal muscle, pressure, smooth muscle, gravity, those types of things. All right. You have lymph nodes throughout your body, but uniquely you have clusters, which you need to know for both the lab practical and the test. So there's large clusters of these lymph nodes in the cervical area, underneath your neck, in your armpit, and in the inguinal area. All right. And if you get to be old enough through life, how many have noticed or experienced a lump under their armpit that was kind of painful? Yeah, yeah. And yeah, most people have, at least once in their life, had a lump under the armpit or a lump in their neck that was sore. And that's exactly right, Christina. If you have a lump under your armpit, your neck, or in the inguinal area, you are in a war. You're fighting an infection. That lymph node is swollen, and it's in battle with whatever the heck it is. Hopefully, it's not cancer. Hopefully, most of the time it's just a regular old infection, bacterial infection, viral infection. Sometimes it's cancer. All right, that's just how it is. I have a close friend that had a very rare cancer, salivary cancer. So the surgeon cut out all the cervical nodes, cut them all out. Because, if the cancer spreads to throughout the circulatory system and the lymphatic system, that's the only way we have to get rid of them is just to cut them all out, which is kind of a horrible thing if you think about it. So, yeah. 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 Good examples from Samantha and Andrea. Yeah, and like I said, if it's viral or bacterial, like a staph, that's okay. You can get over that. If it's cancer, then it's like red flags everywhere. Okay, so the microscopic anatomy, I'm not going to cover this on the test or the lab practical, so you don't have to worry about it, all right? I don't see the need for you to get that deep into it. Just know that you have afferent vessels coming in. It goes through the lymph node, and then when it's done checking it out, then it goes through the efferent vessels, and then onto the trunks and ducts. All right. But again, inside that lymph node are a lot of lymphocytes, which we're going to spend a lot of time on here in a little bit. They're checking for things like bacteria, viruses, cancer cells, and whatnot. But I'm not going to ask you about the trabeculae or the fibrous capsule. None of that. None of that. So you don't have to worry about it. And again, those efferent vessels will merge to form trunks. And again, remember, this is eventually all going to go back into circulation. So you have the lumbar trunks, obviously from the back, if you remember your regional anatomy. The intestinal trunk, that's unpaired, that's just one. The bronchomediastinal trunks, paired, coming from right and left side of your thoracic cavity, then the subclavian trunks from the upper limbs, and then the jungular trunks. All right, so those are all your trunks, and they will ultimately merge into the lymph ducts. All right, so you have the thoracic and right lymphatic duct. That is testable. All right, so the thoracic duct empties 3/4 of the lymph right back into the venous side of your circulatory system, right in between the brachiocephalic vein and the left subclavian vein. The right lymphatic duct was the other quarter, and again, it's emptying right in between the brachiocephalic and subclavian veins. All right. There's a unique little dilated sac called a cisterna cheli. All right, that's right down here, and that's just taking, again, several trunks in there. The only thing that's going to be tested about the cisterna cheli will be on a lab practical, be able to identify that. And it's really super easy. It's just a big bulge. All right, cool. All right, lymphoid organs. The bone marrow, obviously, because we're talking about lymphocytes and all blood cells come from the bone marrow. All right. And then we have the thymus, which is a unique endocrine gland. It's only good for your first 30 or 40 years, and then it just kind of shrivels up. And we'll explain the purpose of the thymus in a little bit. Oops, excuse me. And your secondary lymphoid organs are the lymph nodes, tonsils, spleen, and unique little pockets of lymphoid tissue that we'll talk about in just a bit. All right. So again, the lymphoid organ of bone marrow is because that's where the lymphocytes are created. Way back when, Monday, when we talked about the multipotent hematopoietic stem cell, that's where all your white blood cells are created, including your B cells and T cells that we're going to spend a lot of time on, okay? And then, again, there's almost nothing, take notes, there's almost nothing on this cell that I'm going to test you on, okay? So don't worry about, oh God, Hassels, corpuscles, and I don't care about that stuff, all right? So don't worry about that. So the thymus is something that is very active when you're young, when you're building up your immune system, which will make more sense in a little bit. But as you get to be my age, the thymus really has no function, and I'll explain why that is in a little bit as well. All right. So again, not going to ask you anything on this slide. Just understand, which will be reiterated when we talk about the immune aspect of this, is your T lymphocytes, which doesn't mean probably nothing to you right now. They migrate from the bone marrow to the thymus where they mature, and then go into your lymph nodes and your bloodstream. But again, once you get to be older, it just kind of atrophies, as we say. We've already talked about lymph nodes. Okay, heads up. Everybody paying attention? All right, I want to see a bunch of yeses. So here's just one of those rare occasions where you're going to have histology. So just recognize this on your lab practical as a lymph node, okay? And again, I'm not going to go into, I don't care about the cortex, the medulla, I don't care about any of that stuff, the sinuses, just don't worry about it. Just understand that these afferent lymph is coming into that, and there's a whole host of lymphocytes that are just kind of doing that, they're like your patrol. They're looking to see if we have any kind of infections going on there. If there is, there's going to be a fight, as we're going to talk about in a little bit, and that's when you get those lumps. That's why when you go to the doctor, especially if you do have a throat infection or something like that, they're going to, do the palpation underneath your neck. They're looking to see if you have any lumps or swollen lymph nodes. If you didn't know that, some doctors don't really explain what they're doing, but if they're palpating or they're just pushing on underneath your your jaw and your neck, they're looking for swollen lymph nodes, which would indicate an infection and a fight going on. All right, the spleen. That's the largest of your lymphoid organs. It's dedicated to just that. And again, I'm not going to go into the anatomy. I'm not going to ask you about this histology slide, so you can ignore this one. Not going to go there. And all I need you to know that the spleen is the largest lymphoid organ, and it has two basic functions. It's going to check the blood for those old, decrepit red blood cells that we talked about on Monday. If they're beat up and worn out, there's going to be macrophages that are going to eat them and get rid of them. And then you have the lymphoid tissue that has the lymphocytes that are watching out for any kind of infections you have. All right? So again, I'm not going to really talk any much about white pulp or red pulp or anything like that. Just know this is probably the most important thing on a test you're going to need to know. All right? And its functions. And you're good. All right, tonsils, no, well, they're, these are kind of one of those interesting things that really don't have a great function now as humans have evolved. But we have the pharyngeal, tubal, and palatine and lingual tonsils. This will only be tested on the lab practical. So just look at the slides under the lab handouts, okay, and be able to identify where they're located. Again, the names oftentimes give you a little example of, or give you an indication of where they're found. So lingual, referring to the tongue, palatine to your palate, pharyngeal, pharynx, and then some tubal ones, all right? And again, through evolution, we always had lymphatic tissue where you're exposed to the external environment. So if you get a throat infection, yeah, your tonsils are typically going to be swollen because they're fighting that. But like I said, it's one of those weird things. When I was a kid, way back when, a lot of times if you were having aggravated problems with your tonsils, what did they do? What's that? Tonsillectomy. They just got rid of them, Which, as I got older, I was like, well, why do we have them if we can just take them out? Christine, you're funny, Christine. Yeah, because that's what it was back in the 60s and 70s. Is like, if you're going to get your tonsils removed, it's like, yay, ice cream, ice cream. Yeah, and that was very common way back when. Now, not so much. The only threat of the tonsils, if they get so swollen, they can impair your ability to breathe and swallow. Like I said, back in the olden days, they would just not even think about it and just remove them. So I'm not sure how old Christine is, but yeah, that was the old classic thing is you got them removed, you got the ice cream. Okay. All right. So again, for the testing purposes, just be able to identify where these are on the lab practical and you're good. All right. And then again, you have other, what we call aggravated lymphoid nodules. They're just strategically located throughout your digestive system because again, the digestive system is directly exposed to the external environment because you eat food. All right. So again, malt mucosa, which remember mucosa simply means the inner lining of your hollow organs, and in this case, the digestive system. So mucosa-shorted lymphoid tissue. So again, these are just areas where there's a lot of lymphocytes that are just checking to see if there's anything bad that you may have ingested to fight. Okay, we have aggregated lymphoid nodules. Again, this is in the distal part. I'm not going to ask you about this, and I swear I hate people's names, like Pyre, whoever Pyre was. I'm not going to ask you. And then the most worthless thing you ever had in your body was the appendix. All right, that's a vestigial thing from way back in evolutionary times. It has absolutely no function today, none. Deanna had hers removed. Did it rupture? Yeah, it's like wisdom teeth. Yeah. Like I said, it's again, this is not testable, but the bottom line is that stupid little structure there, the appendix, is loaded with bacteria. Loaded with bacteria. And as long as the bacteria stay in that appendix, it's fine. But oh my gosh, if that appendix ruptures and that bacteria gets out into the rest of your body, that can be lethal. You can be dead in a couple of days, and it's very painful. Deani, did yours rupture? Yeah. So if it ruptures, like I said, those bacteria they're harmless in there because they're protected. But if they get out into the interstitial fluid, then they're called opportunistic pathogens that can they can literally kill you. So yeah. So if your appendix ruptured, that's a bad thing, and you need to get that removed ASAP. Okay. We're done with that. And that's just an overview. So again, on your lab practical, we have literally a model that looks like this, and there's a couple questions on the lab practical about lymphatic, the lymph nodes and the right lymph duct and the thoracic lymph duct and then the clusters of nodes, and again the cervical, axillary, and inguinal area. It's simple, straightforward. Okay. Now for the fun stuff. I love the immune system because I spent 25 years in the military, and this is all about war, combat. These are all military terms to some extent. It's kind of funny because I assumed everybody knew what reconnaissance means. Who knows what reconnaissance means? Yeah. Okay, very good, Vanessa. Very good. We often shorten that, which might sound more familiar to you, as a recon. Who's heard of a recon mission? Yeah. So recon is short for reconnaissance. Call of Duty. All right. So yeah. That's you're looking for the bad guys in your body. You got to recognize them as bad guys, and then you have to respond. So we have to detect the invader, communicate the alarm, recruit our immune cells, and suppress and destroy the invader. Sounds pretty cool, doesn't it? So the two types of immunity we have is innate, which you're born with, and acquired, which you develop over your lifetime. So innate immunity, again, this is what you have when you're born. It's basically those cells that we'll cover again. The neutrophils, eosinophils, basophils, macrophages, those types of cells. You have those when you're born. You don't have you don't have any lymphocytes yet, which we'll explain that in a little while. All right. Your acquired immunity is what you build up throughout your life when you are exposed to all those bad guys. Okay, let me stop for a second. Take notes, because now we're getting into terms that I want to make sure you understand. So an antigen is anything your body recognizes and responds to as foreign. Foreign. So that could be anything from a bacterium to a virus to a cancer cell, you name it. Your body's going to say that's not normal or that doesn't belong here, and you're going to mount an immunological response to. Okay? Now, a pathogen, because I'll use these terms interchangeably in this lecture, a pathogen is an antigen that can do harm. So there are antigens that your body will respond to and say, that doesn't belong here, and they'll try to get rid of it, but it wasn't going to cause any disease. And the perfect example, which falls into this category, are allergens, all right? Allergens. pollen, all that stuff that's in the air. Those are antigens. They don't cause disease. If you're suffering from allergies, that's just your body responding to it. So yeah, Christina's allergic to everything. I had no allergies until I moved to Austin. I swear to God. We're going to talk about vaccines in a little bit here, so just hang on. So I never had, I'm from Las Vegas. I think I may have mentioned that before. And I traveled all over the world, but it wasn't until I got to Austin where all of a sudden, every 3 or 4 weeks, I felt like I was sick. I thought I was coming down with a cold or a flu, and then it would go away after a couple of days. And I'm like, oh, I get it. I'm just allergic to Austin. All right. But again, yeah, it does. But again, the pollen isn't causing disease. All your misery is your own body doing that to you. All right, so you have to be exposed to an antigen, and then your body's going to create an army of lymphocytes to get rid of it. All right, so you need that exposure. You create an army that gets rid of it. You have what we call B and T lymphocytes, which you're going to be expert on in just a little bit. And we'll talk more about the antibody-mediated lymphocytes and cell-mediated. That will make more sense in a little bit. But again, this is where I go into my little thing about society today. Yes, we had COVID. But, and how do I say this? Well, anyway, I don't want to be controversial. I'm just saying I think we kind of overreacted a little bit to COVID on some things, especially with the, hand sanitizer and all this other stuff. But the bottom line, getting back to outside of COVID, because that was toilet paper, yeah, all those crazy things that went on. But outside of COVID, you really actually want to be exposed to antigens and pathogens. Why? I'm looking for a simple little phrase.
It builds up the immune system.
Very good, Andy. Yeah, it builds it up. It's use it or lose it. Very good. Everybody gave you great answers. Yeah, if you're exposed to these things and then you build up armies, then you're good. You are now immune to that particular pathogen that you might have. So, we're in a society where parents, trying to put their kids in the plastic bubbles, and I'm like, no, let them eat something off the floor. That's a good thing. Let them put things in their mouth. And that'll help build their immune system. I tell a cute little story, which today would be horrifying. Yeah. Well, 35-second rule. Yeah, at least 35 seconds. But I tell this cute little story that's true that some people would find horrifying today, some parents. But I was fishing one day. My son is probably 2, I'd say. Sitting on the edge of the water fishing, and my son's splashing in the water. It was shallow there, and then I heard a lot of commotion. I looked down, and no kid, my idiot son had a frog in his mouth, and I'm like, oh my God! I was like, spit that out right now. So I had to go over there and yank. It was just sticking out by his legs. So I just pulled it off his mouth, threw it back into the thing, and I kept on fishing. There are parents today that would probably taking their kid to the emergency room. All right. Okay. So yeah, don't be too sanitary with your young ones. All right. Let's move on. So I guess it's just an overview slide. And it may be educational. So, like I said, we have the innate, which you're born with, neutrophils, eosinophils, basophils, you got it. And then there's the acquired. And again, there's two pathways for this. You have the passive immunity, which means you're getting antibodies from someplace else. All right. And typically, this is what we're talking about when we talk about babies, infants. So, yeah, breastfeeding does confer antibodies that go to the baby and gives them an initial dose of antibodies for protection. And this is very rare, but it's and this was a big thing for COVID. Sometimes you can get antibodies administered to you. So that was one of the big things that was going on with COVID is people that had COVID and had the antibodies from their infection, they would extract those antibodies from that individual and give them to somebody else. It's not very efficient, but we were kind of desperate. And then the active immunity, all right, is once again the most common way, and this got a lot of air on the news and whatnot, and of the naturally acquired immunity, meaning you literally got the infection, you survive it, and now you have antibodies for it. All right, and that's where I get aggravated with the politics and whatnot, because I've been proven right now that if you got COVID, and I don't want to take a account of how many of you have COVID or had COVID, but if you got COVID, you have a very strong immune response against COVID now, yes, he got quite a bit of immunity from that. And we'll talk a little bit more about that. But like I said, I just resented the fact that our government just basically ignored the natural immunity. Those that got COVID survived. And like I said, now I've been proven right according to the science that, yeah, your naturally acquired immunity from having COVID is strong. But again, for a lot of us that didn't get COVID or any other disease, you get a vaccine, all right? And a vaccine, again, the technology today is quite complicated. So I won't go into details, but back in the olden days, a vaccine was basically taking the virus and making it very weak and injecting that virus, that weakened virus, into you so that you could build up an army of antibodies before you got really super sick. But back in the day, when I first joined the military and had to have all these mandatory vaccines, you still got sick, but you weren't deathly sick. You were just like not feeling very well. But our technology has gone quite a bit now where now we use dead viruses or just pieces of the virus. We find the parts of the virus that triggers your immune system, and you're as good and you don't get as sick. And so, Andy, you have a question?
Yes, sir, I do. So is a vaccine, would that be considered passive? Passive immunity? Because it's produced by...
No. The passive,
It's
on the
different.
right side, the passive means you're just getting the antibodies, but you got them from somebody else.
Okay,
All right.
okay.
Okay?
I just
All
wanted
right,
to
so-
clarify.
Yeah, so you didn't create those. They came from another source. All right. So the active immunity is basically we're inducing that by giving you, like I said, in the old days it's a weakened virus. Now it's a part of the virus, and now the sophistication of today's vaccine for COVID is we don't even give you part of the virus. We give you the genetic code in terms of RNA, and this is I hope you guys know a little bit. So we give you the code for the virus in the terms of the RNA. We inject that into you. Your body takes that RNA and makes parts of the virus, and then your immune system responds to it. Does that make sense? Yeah, it is amazing to think that that's the technology we have. So you don't get any of the virus, you just get the code, and your body actually makes to be more specific, it makes the spikes of the virus, and those spikes are enough to trigger the immune response. So anyway, nothing what I just said is on the test. That's just for your edification. No, I don't think it's better. I don't think the vaccine is better than getting COVID. You're going to think I'm out of my mind. I never got COVID, but I wanted to. I broke all the rules. I was like, get me COVID. This is after I got my vaccine. So I know, so I got my vaccine, but I wanted to get COVID because I knew that would afford more protection. But no matter how I tried, I couldn't get it. I literally went, yeah, I know Bukolda. I have lots of friends that got COVID once, twice. I have somebody that I know that's got it 3 times. I'm like, Jesus. I went to parties during South by Southwest where it was packed, shoulder to shoulder, no one wearing a mask, and nothing. But like I said, I thought for sure after a couple of very large parties during South by Southwest with a lot of people, no one wearing a mask, like, okay, I'm going to get COVID now. And nope. Yeah. And again, I really wanted to, I know this sounds crazy, Christina, but I really wanted to experience it because I had lots and lots of friends that got COVID. And I'm like, okay, yeah, I know some people it's really horrible. Others that just said that they just felt weird and couldn't taste food, whatever. All right, enough about that. But no, after my second shot, I never wore a mask again unless it was mandatory. All right, let's move on. Your brother can't taste? How long has that been? Okay. Okay. He didn't get vaccinated? Oh, well, like I said, that's where, like I said, there's a lot of politics because, I don't want to throw a bunch of stuff out there, but 80 to 90% of all of the people that died from COVID were over 60 years old. If you died of COVID at 30, that was just bad luck. And we'll talk about that in a little bit too. All right, so let's get back to our lecture here. So we have the innate and the acquired, and ultimately they work together. So again, here's our monocytes, macrophages, neutrophils. This is what you're born with. And these T cells and B cells are what you acquire through life. And then you have one hybrid that has the coolest name of any cell in your body, natural killer cell. That sounds like a movie. Cool. And we'll talk about that. Okay, so your body defenses. I'm not going to test you on the external stuff. That's kind of intuitive. Your skin, oh my gosh, that protects you from 99% of everything. In fact, if you get 3rd-degree burns and it's life-threatening, it's because of why? Exactly. If you have 3rd-degree burns, it's life-threatening because of infections. All right, and then of course the mucous membranes and lots of secretions, your body oils, all that stuff. But again, I'm not going to talk about that. We're going to focus on what happens once the invader, the pathogen, gets inside your body. And we're going to cover that in great detail. So let's talk about innate, what you're born with. So we talked about the external defenses, but again, that's not going to be on your test. This is GWiz, and if you take microbiology, you will know this stuff. So yeah, your skin is acidic. Microbiota. Okay, so let me just throw that there. So yeah, you have bacteria that are your friends, and you have bacteria that are not your friends. But any bacterium can be bad if it gets past those external defenses. So yeah, whoa, I don't know what just happened there. So yeah, typically your skin is a little acidic, and that pretty much keeps you protected from most bacterium. I never understood that. There was a commercial way back when. It's probably because I don't think it exists. But it was like talking about deodorants, and for women there was a pH balanced. And I'm like, what does that mean? pH balanced. I don't know if any of you are old enough to remember those kind of commercials. You want your skin to be acidic. Okay, and then this is what's going to be on the test here. Okay, so phagocytosis, we want to eat the bad guys. We have the inflammatory response, which is again one of those things that just doesn't serve much of a purpose anymore. Then there's our friends, the natural killer cells, and then something that's going to be new to you, that's the complement system and the interferon. All right, so phagocytosis. We want to eat infected cells. We want to eat bacteria. All right, so, and any dead cells in your war. So we have these phagocytes, and here's your gross thing to think about. So when you get an infection, you know what that pus is?
Is it
White
a
blood
buildup of white blood cells? I think Andy was
What's that?
about to say that. White blood cells? I think Andy was about to say the same.
It's white blood cells and dead cells. It's like the carnage after war, okay, with all the dead bodies on the field. Right? So that pus is a ton of white blood cells and dead cells and the cells they killed. It's like I said, if you ever watch one of those old movies where they had a battle, like Braveheart, where they have all these bodies on the field after the war. So that's what that is, if you didn't know that. Dr. Pimple Popper. I just saw that. Oh, God, Andy, where did I just see that? Dr. Pimple Popper. That's from something. Yeah.
It's on TLC. That's what I'm shooting for in life.
It's on TLC. I don't know where I saw that. And it's like, what the hell is Dr. Pimple Popper? So that's a person?
Yes, sir. She's an actual dermatologist, and she pops people's like humongous growths, and a lot of them are cysts that have just like a collection of dead skin cells, white blood cells. It's amazing.
That's crazy, because I don't know where I saw that. It had to be something I was reading, and it said Dr. Pimple Popper. I'm like, what the hell is that? Is that some sort of... So now so you just educated me. That's an actual person that pops large pimples and cysts. All right. It's probably too much information, but I do get a facial once in a while, and I always like how they call, okay, now we're going to do our extraction. And I'm like, okay, that's what you say when you're popping pimples or whatever. All right. So, yeah, fancy name. All right, so phagocytosis, this is important here. So you have these phagocytes, macrophages for the most part, and they started as a monocyte. And again, this is going to be something you'll identify in your lab practical, a monocyte. All right. Some are just hanging out in your capillaries, and they're just kind of like just watching stuff go by and looking to see if there's anything bad in your bloodstream. If you have an infection, we have a term called diapedesis, which means these macrophages are going to leave your capillaries and go into your tissues, into your interstitial fluid. And what's going to cause them to do that is a process called chemotaxis. And what this means, think of it, chemical taxis, think of taxi. When you have an infection or damaged tissue, those cells will send out an SOS, if you will, via a chemotaxin, a chemical that's going to attract the white blood cells to the area to do battle. All right? So we have are macro, meaning large, macrophages, and the microphages, which include our neutrophils, eosinophils, and our dendritic cells. You may have heard dendritic cell when you had AMP1 in your integumentary system. They kind of cruise around in the skin. All right. So again, your job on the lab practical is to identify these cells under the microscope. So refer to your lab handouts and your slides. They give you pictures. All right. So the monocytes, again, you identify them in the bloodstream as having a nucleus that looks like a kidney, and they will differentiate or evolve into a macrophage. You have some macrophages, like I said, are just hanging out in your bloodstream and just watching to see if there's any pathogens going by. And then the monocyte that turns into a macrophage, that leaves the circulatory system and now is looking for the infected or damaged area. So again, neutrophils, multi-lobed nucleus. They have a lot of weapons at their disposal. They're the first ones on the scene because, again, what you need to know is 60 to 70% of your white blood cells are neutrophils. All right. So they have lysozymes. Remember what lyse means, to split. And this means it's an enzyme, so they can destroy bacteria. They release proteins that act like antibiotics. Who's taken micro? Okay, so I'm going to task those that have admitted they took it. So when I say antibiotic-like things, what does an antibiotic do to shut down a bacterium? Does anybody remember that from their micro?
I think it immobilizes it. I can't remember for sure, but it doesn't exactly kill it, but it stops it from doing its normal processes, I believe.
That was very good. That was very good. That's a good answer. All right. Yeah. So antibiotic just clings to a bacterium and pretty much immobilizes it until it dies. It can't do anything. It can't multiply. It can't do anything because it puts a coating around the cell wall of a bacterium, so it's just done. It's just handcuffed. So yeah, good. All right. I just want to make sure for those that haven't taken micro that they mean what we mean by antibiotic type of thing. And it has oxidants that are like bleach that also destroy bacteria. So they got a lot of weaponry. Eosinophils, they have a more specialized thing where they attack parasitic worms, larvae of worms. And I'll explain what antibody-antigen complexes are in a little bit. And then dendritic cells, like I said, they're found in your skin. And just kind of wandering around looking for things that shouldn't be there. And we'll have a little bit bigger role for the dendritic cells as well. Okay, and this is just a gee whiz. This is not really testable, all right? But yeah, so once one of your phagocytes recognizes something that's foreign, that will trigger this phagocytic response, they ingest the bacterium, then they have lysozymes that break it down, and then they get rid of it. There's nothing really on this. That's just to give you an idea what's going on there when we say phagocytosis. This is an important slide. So chemotaxis, like I said, that's sending out a signal that there's something wrong. We have an infection, we have damage, the damaged cells. I'm going to send out a message, a SOS message, help, help, help. And we will have our phagocytes make their way to the area. So to give you, think about it this way, all right? It's the same principle when we talk about chemotaxins is having a hunting dog or a bomb-sniffing dog or whatever, God, dogs can I think dogs can even smell COVID now, which is amazing. So again, we're going to send out those chemotaxins, and these phagocytes are going to follow the scent or the trail, if that makes sense. Opsonization. And the way you're going to describe this on your test is opsonization is, are you ready for this? Mark for Death, which is one of my favorite Steven Seagal movies. Most of you don't even know what I'm talking about because it's really old. It's like in the 70s. So Mark for Death. This is basically putting a marker on the cell membrane of the bad guy so that your phagocytes know that it needs to be phagocytized. The markers are called opsonins, no big deal there, all right? And then on the phagocyte, they have what are called TLRs, toll-like receptors. And their job is to ensure that what you're going to eat is indeed a bad guy. So if you look at the very bottom here, here's my phagocyte, there's my bad guy, the pathogen, and the phagocyte has opsonins. In this case, it's antibodies. There are several different types of opsonins, marked for death things. And so the phagocyte is going to respond to the opsonins through their TLRs, and that will trigger the phagocytosis. Because again, we don't want to eat any of our good cells. Does that make sense? So how do we define, which is going to be on your test? Yes, Andy.
So you said that the TLRs are, their job is to like double check and balance that it is actually something that is kill worthy.
Exactly. Very good way to say that. Okay, yeah. So those receptors, they're going to be on the phagocyte, and when they bind to opsonins, that will trigger, like, okay, yeah, double check. Yes, we need to destroy this. And again, it's to prevent you from destroying things that you don't want to destroy. So, and we're going to talk, this will make more sense in a little bit. I keep saying that, I know, but hopefully we'll put this all together. All right. Beautiful. So TLRs are receptors on the phagocyte, and once they bind to an opsonin, that will trigger the phagocyte response. UT. All right. I think we're done with that. And then we have the inflammatory response, which is right up there with your stupid appendix that serves much of no purpose nowadays. All right. So originally, your inflammatory response was to open up those capillaries so that the white blood cells could leave the capillaries and go to the injured area. All right. So the problem with this, it's a bad system because most of our injuries that cause inflammation has nothing to do with a pathogen. When you sprain your ankle and it swells, that had nothing to do with a pathogen, but it's still going to swell. And so that's right. Okay, here's you're just, somebody impressed me. And so if you sprain your ankle, what's the little acronym? All right, Joshua, good job. Which stands for what? What does RICE stand for? Rest, ice, compression, and elevation. You don't agree with that, Joshua? What is your dissent?
No, I think honestly, continuing to keep it moving helps with keeping fresh blood going in and speed up the healing process. No, I definitely don't agree with CBD, but I mean, I sprained my ankle numerous times. My job entails that happens a lot on the job, and when people do the rice, they're out a lot longer injured than those who just slow down the pace and continue to use the injured ankle.
All right, well, that's a topic for debate. But the way I look at it is, if you injured that area and you're still using it, you're just going to aggravate it even more. It's a vicious cycle. It's a vicious cycle.
No, yeah, I agree with that. I mean, it does need, it can get worse. I think it depends on the severity of the ankle injury.
Yeah, I will agree with that. But like I said, a lot of times if you injure something, there's damage, significant damage, and you're still trying to, use it, then it's going to cause more damage, cause more inflammation, and it's a vicious cycle. So you want to stop that inflammation at first, and then, you want to get off of it as soon as possible. I agree with that, 100%. That's part of the rehab. I'm very familiar. I have had many sprained ankles, but those first 3 or 4 days, you want that swelling to go down, and then, get back working. But you don't want the inflammation, because it really doesn't do much good. This is your gee whiz fact. Most of the people that have a spinal injury, from falling off a horse, most of the damage is from the inflammation caused that really causes more damage to the actual spinal cord than the original injury. That's why I don't know if you guys are into this stuff, but yeah, in football and NFL, if there's somebody that they suspect that has a spinal cord injury on the field, the first thing they're going to do is what? Anybody know? Well, they're going to stabilize that, but as far as what are they going to do to prevent further damage to whatever may have happened on the field? They're going to put them in the ice bath. Anti-inflammatory, yes, and put them in an ice bath, because again, your biggest worry is the inflammation is going to cause more damage than the original injury. So I understand where you're coming from there about you use it or lose it, but you need to get rid of that inflammation. Yeah, Christina has a lot of stuff going on in her life. Yeah, and Joshua, cortisol shots are the greatest thing on the planet Earth, all right? I love cortisol. I'm old, but I'm an old jock. And, oh my God, so cortisol shots are amazing. I had them in my knees, my shoulders, my ankles. So yeah, but again, it's getting rid of that inflammation. Okay, we've gone way too long in this. But like I said, inflammation is good if you have an open wound, all right, because it gets your white blood cells there, which are going to do the battle, all right? So all you need to know about the inflammatory response is that's where your mast cells come into play, and they release the histamine. Histamine is an inflammatory chemical that opens up, causes vasodilation, opens up those capillaries, and they become very leaky, which is what that swelling is all about. But what do we have now? We have all sorts of what? Say it. Antihistamine. All right, so most of our focus now is stopping the inflammation. All right. And again, yeah, because again, allergies, and I'm going to talk a little bit about that in a little bit. Most of your allergies is an inflammatory response that you don't need, so you stop the inflammatory response. Very good. All right, and the only thing here, again, this is kind of gee whiz, is this little thing here. Again, this is not testable, but the swelling, redness, heat, that's incidental. That's not what the purpose of the inflammatory response. The inflammatory response was to get the white blood cells to the area. All right, enough. Nice talk. I enjoy the conversation. on inflammation, and that's cool. Christine, yeah. It is a cool name. I mean, really.
Sorry, I just get really excited about them. I think they're so cool.
Yeah, so these cells are amazing because they go straight after your bad cells, your virus infected cells and your cancer cells, and they literally, it's like hand-to-hand combat. They go in there, they connect with the bad guy, and they just destroy it. All right, and so what you need to know for test purposes is this natural killer cell. Again, we need to have those markers, and the natural killer cell binds to the bad guy. And again, like Andy was saying, I want to double check that this is a bad guy, that this is indeed a bad guy, and I need to kill it. All right, Christine, you're a little bit ahead on MHC stuff. We'll get there in a second. So, again, the natural killer cell will bind to the target cell, and once it understands that this is an infected cell or a cancer cell, it's going to create what are literally called perforins. And think about that. What perforin probably refers to what?
Perforate. Like,
Perforate. Very good. Perforate. All right. Very good. So you're going to basically, the killer cell is going to make these proteins that are going to make a hole in the cell, and the cell is going to explode. Who can impress me by telling me why the cell would explode if I put a hole in it? One word starts with an O.
osmosis.
Outstanding. Very good. Very good. Outstanding.
I got a gold
Ashley.
star today.
Yeah. Good job, Ashley and Vanessa and Joshua and Christina and Cristobal. Yeah, osmosis. Yeah. The water just is going to rush in. So these cells knew about osmosis well before we did. They know how it worked. So yeah, beauty. Okay. All right. And then we have two systems that are very complicated, so we're going to keep this really simple. So the complement system is these, you have a bunch of proteins that are produced by the liver that are circulating in your body right now. And they work together to provide protection. And again, this is a tremendous amount of graduate level research at how the complement system works with COVID. COVID has everything to do with the complement system, but we're going to keep this simple. And then we have what we call interferons, and we'll explain those in a second. So the complement system, again, this is so simplified. It's way more complicated than this, but it's good enough for this course. So the complement system works just like the natural killer cells. They have these proteins that embed into the bad guy and make a hole. And they even give it a really cool name, membrane attack complex. How cool is that? Or a MAC. And they just put holes in it. And so then we have osmosis and boom. All right. The complement system has many other roles. Again, here's the big in bold is to lyse the bacterium. But they also serve a role as chemotaxis, or SOS message, opsonins, mark for death, and they trigger the inflammatory response. Excuse me, I'm having a little allergy attack here. So, don't be afraid of this slide. I'm not going to ask you anything about it. I just thought you'd be interested is how the complement system does work with your acquired immune response. They actually work together, and this is where the big business of COVID comes in, which again, we don't have the time. It's way beyond this course. But so these little Y-shaped things are what we depict antibodies to be. So you can see a lot of these Y things. So these antibodies bind to the surface, and then the complement proteins come together, and it's kind of like a drilling rig. You know, a drilling rig. We're like, okay, we got the platform, the antibodies, and now the complement proteins act as a drilling thing, and then they put the holes in there. But there's nothing on here that's testable, folks. It's just, to me, fascinating. Interferons are what we thought was the magic bullet for cancer and lots of other things. Turned out to be not so much. They work to some degree, but all right, those that took micro, how does a virus work? What does it do?
So it takes in the DNA and it copies it, or it takes over the host DNA.
Yeah, that's a good answer. That's a good answer. I'm gonna go to my camera real quick for this. All right. Hold on. Hold on. Yeah, my camera doesn't seem to be working right now. Why isn't it working? It doesn't work on that. I'm just trying to talk my way through this. Ah, it's working now. Okay, because some of you haven't had micro yet, so here we go. So for those that haven't taken micro, what a bacterium does is, here's my cell. And I'll just draw a nucleus in there so it looks like a cell. And what these evil bacteria do is they bind to a receptor on the cell, and they trick the cell. And they're thinking, okay, it's good, it can pass. And what this evil virus does is it injects either DNA or RNA. And this gets the cell to actually make the proteins to create more viruses. And then the viruses multiply, and eventually they take over the whole cell. The cell dies, and then the viruses are released, and then they go to other cells. Everybody with me so far? All right. Okay. All right. And yeah, and so you have two types of viruses. Ones that literally directly inject the DNA, so it goes right to the transcription translation process. Others inject the RNA, which are the nastiest ones. Who can give me an example of an RNA virus? Yeah, COVID. COVID. Okay, all right, besides COVID. Before COVID, SARS, okay. What are the more common ones? No, not the flu. Hepatitis. No, not hepatitis. What? Come on, guys. Hepatitis, yeah. What are the more common ones? HIV, very good. HIV, all right? Scabies. Oh, I wanted to hear HIV and herpes, all right? Herpes. And these are really extra bad. The HIV and the herpes are bad because they're forever, as you know, because the RNA is converted to the DNA, and then that's spliced into your own chromosomes, your own genes. So it's if you have herpes or HIV, that's part of your genome. That's part of your chromosomes now, forever. All right? It never goes away because, again, it's part of your DNA. Now, they're not always transcribed and translated, but you've heard of herpes breakout, where all of a sudden you're doing fine, and next thing you know, you got some nasty little sore somewhere. And that's because something, typically it's stress, triggers its replication. All right. Okay. So the way interferons work is, and let me make this quite clear, all right, for everybody. Once one of your cells is infected, it's a goner. It's a goner. It has to be killed because now it's just a virus-making factory. And so you want to kill it. So when you get a cold or a flu or whatever, all those cells that cause that inflammation, your sore throat, the swelling, those cells will be killed. No cell gets infected by a virus and then recovers. Does everybody get that? You must kill them. All right. So what happens in your body is you got a cell over here that's healthy. And this cell says, hey, talking to this guy, hey, dude, I just got infected. I'm screwed, but save yourself. So I'm going to send you over some chemicals that can help you protect you from replicating this virus. Does that make sense? All right. Okay. So let me go back to my slides. So that's what this slide is saying. So this cell right here is screwed. All right. It got infected. A natural killer cell is going to kill it, or a cytotoxic T cell is going to kill it. It's a goner. Oh, you don't see it? Hold on. Okay. So, you guys can see it now, right? We're good? Yeah. All right. Okay. So this cell is a goner. It's going to be killed. But what it's going to do is it's going to send out some chemical signals called interferons that will communicate to the healthy cell and say, save yourself, save yourself. So the cell can produce what we call antiviral protein blocking chemicals here. And so the goal is, okay, this cell is aware that the virus is there. If the virus introduces its DNA and RNA, we're not going to let it reproduce and save ourselves. And this is where basically most of the medications for HIV comes into play. I don't know how many, I mean, it's not, obviously not a big topic since COVID. Certainly HIV was a thing for a long time. So most of the medications that we have for treating HIV is these antiviral protein drugs that say you're not going to replicate. And so if we can stop the virus from replicating, then we can stop the virus. So that's where most of our technology is to just stop the reproduction process. Any questions with that? Again, for this on the test, this is all you need to know right there. All right. Don't worry about the type 1, type 2. We're not going to go in the detail. All right. But again, interferons, we thought that was the magic bullet for cancer and HIV and all that stuff, but we end up having to create our own version of interferons for HIV. And we're getting there with the cancer stuff. All right. let's take a break. Take a 15-minute break and we'll wrap this up. Any questions? So let's be back at 7:30. And again, I'll create a new site because we're taping this and I don't want 15 minutes of blank to go. So we'll have